Hey Valley Middle, welcome back to another G67 math video. Tonight we're going to be focusing on the distributive property. Before we do that, let's start off with our trivia question. What movie is this famous scene from? And if you know the name of the movie, when was it released? Take a guess. All right, tonight our targets officially are, I can use the distributive property to anyone, Bueller, rewrite expressions, and combine like terms. Let's do this thing. Use the distributive property to help Sloan and Ferris rewrite each expression and combine the like terms. Well, we've got 3 times the quantity of a plus 5. Well, the distributive property says that we can take and distribute out or pass out this 3 to the a and to the 5, like I've done here. 3a plus 3 times 5. I keep the same sign in the middle. I just pass out the multiplication. I can simplify that to 3a plus 15. And that's as far as I can go without knowing what the variable a stands for. I can take this one down here, though, and take it one step further. Not only can I pass out the minus 2 to the d and the minus 2 to the 3, I can also do something else. Watch what happens here when I distribute this out. So now I have minus 2d, and I'm going to add minus 2 times a minus 3 plus that 5d. When I simplify it down, I've got a negative 2d plus 6, we have a negative times a negative here, plus 5d. So I've got a minus 2d and a positive 5d. I can combine that and say that really what I have here is 3d plus 6. See how I combine the like terms there? 2d and 5d are like terms. This one is a different sign, negative of course, but I can still combine them. All right, we'll take a look at that more carefully here as we look at some vocabulary. Mr. Rooney is going to be talking with us on the phone, apparently. The distributive property, first of all, we've got a times b plus c is really the same as ab plus ac. That's what we were doing in that first page, but I'd like to give you kind of an abstract form to make sure you understand that. The next word is term. This is either a single number or variable, or a number and variable that are multiplied together. Terms are separated by a plus or minus sign. Take a look at these. 3a, 2, and y. Those are all terms separated by a plus sign and a minus sign. A coefficient is when a term contains a number and a variable, like 3e or 3a. The 3 is the coefficient, the e is the variable. A constant, that's a term without a variable. So I've got 2x plus 5. This one doesn't have a variable. That's a constant. And then like terms are like 3x and 2x, or minus 2d and a positive 8d that we had on that first page. All right, let's see what you remember here. So I've got an expression here. Can you identify the terms? Here they all are. Those are all separate terms, 5 of them. How about the coefficients? There's 3 of them. Here's 2 here, and there's 1 more going down, but I didn't put an arrow there because it would interfere with my word constants. These are constants here. The only one I've forgotten is like terms. Can you identify the like terms in that expression? There they are. You could combine those. You've got a positive 5b and a minus 2b. That's really the same as 3b. Okay? Too bad it's not 2b or not 2b. That's lame. All right, let's keep moving. All right, let's look at a few more examples here. So now we have 5 times x plus 2y. Can you use the distributive property? Let's see if we do that. Okay, 5x plus 10y. I passed out, I distributed up that 5, so I've got 10y's now. Okay, and 5x's. How about this one here? Try it. What would you do? Well, let's see. I'll get my arrows to appear there. I like putting these in, especially when it becomes complicated. This one up here I thought was pretty easy, but I do have them there if you want them. So this is 3 times x, 3x times x. Well, that would be 3x squared, because now I've got x times x, so that's where the x squared comes from. But then I also have 3x times y, so that's where I get the 3xy. Now I've got to add that 2xy. So 3xy and 2xy, those are like terms. I can add those and make it 5xy. So really what I have here is 3x squared plus 5xy. Okay? Take a look at this one here. All right, I think let me just give you some help here. Be minus 2 times a, so that would be like minus 2a, and minus 2 times b, that would be like a minus 2b, right? Right, except for the squared isn't supposed to be there. Sorry about that. So what I've got here now is I've got a minus 2a, a minus 2b, and I still have this dangling term here, this 8b. Well, these are like terms. I can combine those. Sorry about that, square. So now I've got 2a plus 6b, because I have a positive 8 and a minus 2. So that leaves me 6 positives, 6b, 2a plus 6b. All right, on this one here, see if I can get that other one to pop in there. I can't quite get it. I know it's somewhere. There it is. I have a minus 3a, and then I have a negative times a positive. So when I put that together, I would have a minus 3a, and I would have a plus 18, because negative times a negative is going to be a positive 18. Plus I have the constant here, this term here, plus 12. So after I simplify that, I can gather up those like terms. I'm going to have a minus 3a plus 30. Okay? Let's take a look at a couple more examples before I have you try some on your own. All right. Lots of letters here. Well, we can still do this. Now I'm going to have xy plus x2, but we'll probably call that 2x, right? And then I've got this one over here too, minus 3y, and then I've got minus 3 times 2x, so that's really a minus 6x. So let's see. xy plus 2x minus 3y minus 6x. Good. Is there anything there that I can combine? You do see some like terms there, right? You've got a positive 2x and a minus 6x. Well, you got a positive 2 and a minus 6. That's really a minus 4x. So I've combined terms there too. Okay? All right, on this one here, let's see if I got my little arrows. There they are. All right, so I'm going to have AB plus AC. We got that right. And then I'm going to have BA plus a minus BC, because this is a negative. Do I have any like terms here? Well, at first it doesn't look like it, but the commutative property of multiplication says that AB is going to be the same as BA. So I can combine those, and I can just move this guy and call this one AB. And so really what I have then is 2 times AB plus that AC minus the BC. That one there you might not have caught, so that was a good one to go over. All right, one more before we cut you loose on your own here. I hate these ones here where they've got the distributive property. It's kind of like backwards. You can do it. I usually rewrite it. It's down here someplace. There it is. I usually rewrite it like this. I think it's just easier to use. So then I've got my 3a plus my 3b. I've got minus 6, and then I also have this minus 4. So I do have some like terms. The a's and b's are separate, but I got a minus 6 and a minus 4. A negative 6 plus a negative 4, well, that's a negative 10. You keep the sign. You keep the signs when they're the same like that. Just add them together. All right, I think it's time for you to try a couple on your own here. Why don't you try these ones here? Pause the video, see if you can figure out how to use the distributive property to combine like terms. Okie dokie, let's see how you did. All right, this first one, minus 4ab plus 24a. We got 4 times 6 is 24. These are both negative, so that's a positive 24, and we still have the a as well. All right, the next one. Well, this guy stays here, but you've got 2x minus 6. Well, you can combine this x plus the 2x, and when you combine like terms, you're going to have 3x minus 6 there. All right, so this one here, if you did this one correctly, you had, I'm just going to slide this out of the way. If you did this one correctly, you would have had 5x plus 5y minus 2x plus 2y. So you get a minus 2 times a minus y. It's a negative times a negative. It's going to be a plus 2y. You can combine the y's here. You got a plus 5 and a plus 2, so you really have, and you've got a plus 5x and a minus 2x. So you can combine both of them. You've got 3x's and 7y's. 3x plus 7y. And this one here, well, this would give you 2x squared. And then you're going to have 2x. And then you're going to have 3x. And then you're going to have 3. So you can combine some things. You can't really combine the 2x squared and with the 2x plus the 5x. You can combine these two here. Okay? Because 2 times a variable isn't the same as maybe a variable squared. If you just attack these on there, it wouldn't work out to be the same answer. So we got 2x squared, plus we got 5x, plus 3. All right, time for your ticket to the show. Use the distributive property to rewrite these expressions and combine like terms. I'll give you a second to copy those down. Okie dokie, here's Ferris Bueller from the movie. Gave you a few good shots of the movie as we went through the slideshow. Here's my favorite quote of his during the movie. Life moves pretty fast. If you don't stop and look around once in a while, you could miss it. Great line. The official title of the movie is Ferris Bueller's Day Off. It was released June 11th, 1986, about 30 years ago. PG-13, check with your parents on watching that. It's a pretty fun movie about a couple of kids and 3 kids who escape school and go to Chicago for the day. Classic scene in their dad's, and Cameron's dad's Ferrari. And Ferris ends up singing at the German Day Parade, Danke Shane, and then there's a twist and shout that's pretty fun too. So, all right, hope you get to watch it sometime. I think you'll enjoy it. Thanks for listening, and I hope you feel stronger about your ability to use the distributive property to combine like terms. Have a good evening.